A wave is a disturbance that transfers energy through matter or space. Each wave has an amplitude and a wavelength. The wavelength is simply the distance between two consecutive waves. Take a wave source. Imagine a point A. If the wave source starts moving towards A, then the waves propagating towards A will compress and will have a decreased wavelength than the original waves. If the wave source starts moving away from A, then the waves propagating towards A will expand and will have a longer wavelength than the original waves. This is the Doppler's effect or the Doppler shift. Atoms of different elements absorb light of different wavelengths. Due to this absorption, certain dark lines appear on the light spectrum of that particular element. This spectrum is unique to every element in the periodic table. This is the hydrogen spectrum. Notice the dark lines. This means that the hydrogen atoms absorb light of these specific wavelengths. So, the light spectrum of a star which is composed of hydrogen will have dark lines appearing on the same spots as those seen in the hydrogen spectrum.
And on a side note, this is how we determine the composition of stars which are billions of light years away from us. But back to the point. The Doppler's effect holds true for light as well. But here's why the Doppler's effect has a significant role in our interaction with light. We perceive lights of different wavelengths to be of different color. The light of the shortest wavelength that our eyes can see is violet colored. Upon increasing the wavelength, the light appears indigo, then blue, then green, yellow, orange, and finally red. Red colored light has the longest wavelength on the visible spectrum of light.
Think of our wave source again. Now our wave source is giving rise to waves of light with light of some wavelengths absorbed. The apparent increase in the wavelength when the light source is moving away from us will cause the dark lines to shift towards the red end of the spectrum, aka the redshift. Renowned astronomer Edwin Hubble observed that the light coming from stars of different galaxies was redshifting. All the galaxies, for some unknown reason, were drifting away from us. Thus, he famously concluded that the universe was expanding.
But that's not the end of it. In 1907, Einstein described a phenomenon whereby particles of light lost energy upon interaction with gravity. This energy loss caused an increase in the wavelength of the light. This is the gravitational redshift. So, is the Doppler's effect not the reason of the redshifting of the light coming from the stars? Honestly, we don't know. But is the universe expanding? Well, much before Edwin Hubble, physicists had used Einstein's relativity to predict that the universe is expanding. But will this expansion ever stop? Is a cold death of the universe inevitable? Well, that's a story for another day.